Alright, let's explain the difference between the solution to the equation 4x over x minus 2 is equal to 3 and the solution to 4x over x minus 2 is less than or equal to 3. Well, we can notice that one of the questions is regarding an equation, the other one is an inequality. So for the equation there should just basically be one solution, but for the inequality we have an interval, and the interval could be multiple solutions of x that will satisfy that interval in question. I think the easiest way to kind of demonstrate this is I'm going to solve both cases, right? So I'm going to start with the equation. So you have 4x over x minus 2 is equal to 3, right? And in this case, we get 4x. I'm going to multiply by x minus 2 to both cases, right? Cancel this out. 4x is equal to 3 times x minus 2. So you get 4x is equal to 3x. I'm going to expand this guy out. Minus 6. So 4x, if I move the 3x here, minus 3x is equal to negative 6. So x is equal to negative 6. So that is our solution for this case, right? You can also notice that x cannot equal 2. That is our restriction, right? So it's important to kind of mention out there's restriction because it is a rational expression, right? So x is equal to negative 6. Now I'm going to take a look at the next scenario, right? And in this case, I'm going to get 4x over x minus 2 is less than or equal to 3, right? What I want to do to solve a rational expression is I want to move the 3 to the other side. So you get 4x over x minus 2 minus 3 is less than or equal to 0, right? So you always want to, if you're trying to solve an inequality, try to let one of the sides equal 0, or be greater or equal to 0, less than or equal to 0, greater or less than 0. So let one of the sides equal 0, right? Now what you want to do here is you want to simplify this, and the way you can do this, I'm going to make sure that the lowest common denominator here is x minus 2, right? So what I'm going to do is I'm going to multiply this by x minus 2. Okay, let's just not. So we get times x minus 2, and we get 4x minus 3 times x minus 2 over x minus 2. Okay, so it looks really familiar to the previous question. We can see that the method, the procedure is a little different. So you get 4x minus 3x plus 6 over x minus 2. And if I simplify this, I get x plus 6 over x minus 2. And this should be less than or equal to 0. So if I want to solve for my inequality, what I want to do is I want to first figure out some intervals. So the intervals are created by finding your critical numbers. Your critical numbers can either be your x-intercepts as well as your vertical asymptote, right? So your critical numbers here, x can be equal to negative 6 or 2. I'm going to plot these on my number line here. So let's say that this is negative 6, right? And this is positive 2. So one of your intervals is negative infinity and negative 6, right? It should be inclusive because of the fact that we have less than or equal to 0. So 0 also counts, negative 6 and positive 2. Once again, we're using square brackets because the points are inclusive, because we can look for values that equate to 0. And then positive 2 and infinity. And notice that negative infinity and positive infinity cannot be included in an interval because infinity itself is a continuum. Now, these are our three intervals, negative infinity to negative 6, negative 6 to 2, and 2 and positive infinity. What we're going to do next is we're going to solve this inequality by creating an interval table, right? If I create an interval table here, whoops, let's just make some space. I'm going to put my intervals on the top row here. X belongs to these intervals, so negative infinity and negative 6. Right, negative 6 and 2, and positive 2 and positive infinity. And then I'm going to put my factors here. So this is x plus 6 as my numerator, 1 over x minus 2 denominator, and let's call this our function f of x, so just be easier. Okay, let's call this guy our function f of x. So it's basically this factor times this factor. And then what we want to do is we want to gauge a value from each interval. So from negative infinity to negative 6, I'll let negative x equal negative 7. So negative 7 plus 6 is negative. Negative 7 minus 2 is 1 over negative 9. Right, so this is negative, and then these two negatives times multiplied by each other, the product is a positive. Between the interval of negative 6 and 2, I'm going to let x equal 0. Right, in this case you get 0 plus 6, which is positive 6, so it's positive. 0 minus 2, so 1 over 0 minus 2 is negative 1/2, which is negative. Right, and a positive and a negative will give us a negative. Right, so you can see that in the first interval of negative infinity to negative 6, this is actually greater than 0. In the second interval, this is basically less than or equal to 0, right? So this is potentially one of our solutions. Okay, so let's include this as one of our solutions. And then between 2 and positive infinity, I'm going to let x equal 3, and you get positive 9, positive, and a positive, so this is greater than 0, right? So in this case, the only solution that would work for the scenario, less than or equal to 0, we can basically have this interval, negative 6 and 2, right? So therefore, we can say that therefore x can belong to negative 6 and 2, right, for the expression to be greater or equal to 3. Now you can notice here that there are two different, these answers and the solution, the procedure in getting these answers are completely two different steps, right? So you can see that the equation was pretty straightforward. We just have to solve for it and write the restriction, right? But in this case, however, for the inequality, we actually have to create the interval table, and we have to actually determine which of the intervals worked. Now, there's something that we need to also mention here. You notice here that x cannot equal 2 because there is a restriction. So what we need to do here is we need to actually correct for this. I'm just going to take the square bracket off and make this a circle bracket, and the reason is because vertical asymptotes don't exist, right? So we should actually make this 2. I should have kind of, instead of making this greater than or equal to, I should have made it just greater than 2, right? So you have to kind of watch out for this just in case, right, that it can't be inclusive on vertical asymptotes, right? So the restriction is still consistent between the two, right? So this should also be just a round bracket, right? But beyond that, you can see that the solutions differ significantly between the two types of questions.